Hi everyone, today we're going to study addition of polynomials. First, let us define like terms. Like terms are terms with same literal coefficient, otherwise unlike terms. Let's have some examples here. I have here four terms: 2x, negative 5x, x, 3/7 of x. As I observed, the literal coefficients for all these four terms are x. So they have common literal coefficient. So these four terms here are like terms. Another example, I have three terms here. The first is 5a cubed b squared c. Second, negative a cubed b squared c. The third, the square root of 10 a cubed b squared c. Now, observing the literal coefficients of all these terms, it is common, and that is the a cubed b squared c. So we don't care about the numerical values or the numerical coefficient. Since they have the same literal coefficient, they are like terms. Third example, 10a cubed b squared. Second is 10a squared b cubed. In here, they have the same variables a and b. However, the exponents are different. In the first term, the power is 3. In the second term, the power of a is 2. While here, the b has an exponent of 2. In here, the exponent of b is 3. So they have different literal coefficient. So when we say the same literal coefficient, even the powers must be same. So in this example, for this group of terms, these are unlike terms. Fourth example, I have here two terms, 2a cubed b squared c. The second is 5a cubed b squared. So in the first term here, I have three variables a, b, c. In the second term, I have only two variables a and b. While it is true that the exponents for the a and b are same, but in the second term, the variable c is missing. So in this case, this is an example of unlike terms. Let's go now to addition of polynomials. Let's begin with addition of monomials that are like terms. The rule is given to add the numerical coefficients and copy the common literal coefficient. Let's see an example. 3xy plus 2xy plus xy. So we are sure that this group of terms are like. So we can add the numerical coefficients. I collected the 3, the 2, and the 1. The 1 is the coefficient of the xy. And then for the literal coefficient, we simply copy that same and common literal coefficient. So 3 plus 2 plus 1 gives us 6, and the xy, the literal coefficient, is simply affixed. Second example, 10xy squared z cubed plus 4xy squared z cubed. Again, looking at the literal coefficients, we are sure that these two are like terms. So we can now add the numerical coefficient. So the 10 plus 4, and then we copy that common literal coefficient, the x, y squared, z cubed. So the final answer is 14x, y squared, z cubed. Third example, 4xy squared plus 2x squared y. Looking at the literal coefficients, it seems there is a problem here. In here, x, y are there, but the coefficients as compared with the second literal coefficients are not same. Here is x with exponent 1. Here there is an x with exponent 2. For the y, here is exponent 2. Here is with exponent 1. So we can see here that we can conclude that these two terms are dissimilar. And it says dissimilar terms cannot be combined. So when we are required to put the answer here, we simply copy that same problem. So our answer here is, I simply copied the 4xy squared plus 2x squared y. Let's go now to the addition of polynomials. The rule says combine like terms. Example 1. Simplify. There is a group of polynomial here, 6x squared plus 2x plus 3 plus the second group, 4x squared plus 5x minus 1. So the rule says let us combine like terms. So the 6x squared is combined to the 4x squared. We will get this 10x squared. Next is the 2x and another 5x on the other group. We can put them together. So we add the numerical coefficients. 2 plus 5 gives us 7. And we copy the x. And for the constants, here is 3. In the second group, there is negative 1. So 3 combined to the negative 1 will have the positive 2. So the final answer is 10x squared plus 7x plus 2. Let's see second example. Sometimes problem will come to you like this. Find the sum of the polynomial 2x squared minus 3x plus 5 and the polynomial 5x squared plus 4. We can rewrite this problem like this. Put a grouping symbol to the first group, list here, and then put a plus sign. Then take the second group, put a grouping symbol and place it next to the first group. And then we will go now to combining like terms. So here we have 2x squared. Here there is 5x squared. We can write the answer as 7x squared. And for the negative 3x, there is no term in the other group with the x as literal coefficient. So the negative 3x directly we can place in the sum. Make sure that you don't forget to include that negative 3x. And for the constants, the 5 plus 4 will give us 9. So the final answer is 7x squared minus 3x plus 9. Example 3. The three sides of a triangle is measured at 3x minus 2, x plus 1, and 2x plus 7. Find the perimeter of the triangle. First, we should know that perimeter is the sum of all sides. So we're going to add the sides of the triangle. So P, that stands for perimeter. So I collected the 3x minus 2, that is the first side, x plus 1, that is the second side. The 2x plus 7, that is the third side. And then we simply collect the like terms. The 3x, the x, and the 2x, we combine them together. We'll get the 6x, and the constants -2, the +1, the +7. We will get a +6. So 6x plus 6. This is our final answer. This is the perimeter of the triangle. Hi everyone. Today we will study subtraction of polynomials. First, let us review. Suppose there is an equation a minus b equals c. Naming the parts of these three numbers here, the first number representing a is called minuend. The second number b is called the subtrahend, and the result of this subtraction is called difference. Now let us go to subtraction of polynomials, starting with the first part, subtraction of monomials of like terms, meaning these are terms with the same literal coefficient. The rule is mentally change the sign of the subtrahend, then proceed to the rule of addition. To illustrate, suppose we have a minus b. What we will do, in here the b is positive, we will put the minus sign with a b, and then the operation becomes addition here. So it means to say, in relation with our rule here, in subtraction of monomials, suppose the b is positive. Showing this as minus b means we should change the positive into negative. On the other hand, if your b is negative, we're going to change the negative into positive. And then we will use the rule of addition to combine the a and this b with a new sign, and we will get this variable c, or the difference of c. So let's have an example 1, 5x minus 3x. So for the 5x, that is the minuend, we simply copy that here. Look at the 3x here, this is our subtrahend, so the 3x becomes negative 3x, and the minus sign becomes plus. And then we will apply the rule of addition. Since we have two terms here with opposite sign, we're going to subtract the coefficients, and then we will affix the sign of that coefficient with a greater absolute value. And then for the variable, we will copy the common variable, or the common literal coefficient. So the answer is 2x. The positive 5 plus a negative 3 will give us positive 2, and the variable x is copied. So the final answer is 2x. Example 2, 5xy minus a negative 3xy. So we will change the sign of the subtrahend. From negative, it becomes positive, and the sign becomes addition. So the minuend is simply copied here. Then we will now combine the 5xy plus the 3xy. So we have the final answer as 8xy. Example 3, negative 10y minus a negative 2xy. So again, the second term is our subtrahend, so we're going to change the sign. From negative, it becomes positive, and then the operation becomes addition. However, we can observe here that the first term and the second term are not like terms. Here, the literal coefficient is y, and on the second term, the literal coefficient is xy. So, as a rule, unlike terms cannot be combined. So for our final answer, we will simply copy all these terms. So negative 10y is here now, and then plus the 2xy. So final answer is negative 10y plus 2xy. Let's go now to subtraction of polynomials. The rule is we change the sign of all terms of the subtrahend, then add like terms. Let's see one example. Perform the operation. We have two polynomials here. 4x squared minus 2x minus 7 is our first polynomial, minus the second polynomial, x squared plus 5x minus 3. So the second group is our subtrahend. We're going to remove the grouping symbol for all these two groups. And then for the second group, we're going to change the sign. So the first three terms here are the terms of our first polynomial. Then the second polynomial, we will change the sign of all the terms. The x squared here is positive. In here it becomes negative. The 5x is positive. Here it becomes negative. The negative 3 becomes positive 3. And then we will combine like terms, or we will add like terms. We have here 4x squared. There is a negative x squared here, so we can combine these two. We have 3x squared, and then the negative 2x. There is a negative 5x here. We will combine these two. We will get the negative 7x, and for the constants, negative 7, and there is a positive 3. So it is negative 4. So our final answer is 3x squared minus 7x minus 4. Let's have another example. Subtract 5x squared plus x minus 4 from the 4x squared minus 6x plus 7. So there is a little analysis of the position of the polynomials here. We know that we are putting a minus b in a normal operation of subtraction. But based on the manner of the problem is written, the second polynomial here is considered to be the a, and this first polynomial here is our b. So it means to say we're going to put the second polynomial first. That will be our minuend, followed by our subtrahend. And then, as a rule, we're going to remove the grouping symbol, but we will change the sign of all the terms of the second polynomial. See here, the 4x squared minus 6x plus 7 are simply copied here without the grouping symbol. Then for the second polynomial, the 5x squared is positive here, it becomes negative. The plus x becomes negative x, the negative 4 becomes positive 4. And from here, we will combine similar terms. The 4x squared and the negative 5x squared, we can add together. We will get the negative x squared, negative 6x and negative x with both negatives. We will combine them. It becomes negative 7x. And for our constants, the 7 and the 4 becomes 11. So the final answer is negative x squared minus 7x plus 11. Let's have example 3. 2x cubed minus 5x plus 1 minus the quantity 3x squared minus 5x minus 6. So we will follow our rule. The second polynomial is our subtrahend. We will change the sign of all the terms of our subtrahend. So 2x cubed is here, minus 5x plus 1. And then the 3x squared becomes negative 3x squared. The negative 5x becomes positive 5x. The negative 6 becomes positive 6. And then we will collect and combine like terms. The highest power here is the cube. So it seems there is no other variable with cube. So only this one, the 2x cubed. We will simply copy this. And for the followed by this negative 3x squared, there is no other term with a variable x squared. So we will put this negative 3x squared in the final answer also. For the negative 5x, and there is a positive 5x here, it is cancelled. Then for the constants, it is 1 plus 6. It becomes 7. So our final answer is 2x cubed minus 3x squared plus 7. Thank you for watching. See you again next time.